is I, Decode, and we are going to do another one of those hacker rank challenges in C Sharp, so we can brush up on our C Sharp skills. This one is part of the interview preparation courses, and specifically the greedy algorithms. It is an easy challenge called luck balance, and it'll get us familiar with some extension methods using the system.link, and we're going to be looking primarily at lists, .add, .sum, .take, and .skip. So if you want to learn some really valuable information about these extension methods and solve the challenge together, I suggest you follow along. Otherwise, as always, you could just look in the description and find the source code on my GitHub, and just literally copy and paste it and put it in the challenge and pretend like you actually know what you're doing with the code. But yeah, have fun, follow along, and let's get started. Alright, everybody, so yeah, we're going to be doing this greedy algorithms within the interview preparation kit. Go to greedy algorithms and then go to luck balance. As you can see, it's easy for a max score of 20. It's going to be an easy one, but again, we're going to be learning some of the basics of C# with this, and that's the real point. So with luck balance, Lena is preparing for an important coding competition that is preceded by a number of sequential preliminary contests. She believes in saving luck and wants to check her theory. Each contest is described by two integers, Li and Ti. Li is the amount of luck associated with the contest. If Lena wins the contest, her luck balance will decrease by Li. If she loses it, her luck balance will increase by Li. It's kind of a weird... The luck balance is in Lena's head. She has some sort of OCD. She believes in balancing out the act of taking these contests with the luck that she has. TI denotes the contest's importance rating. It's equal to 1 if the contest is important, and it's equal to 0 if it's unimportant. So this is basically just like either 1 or 0. If Lena loses no more than K important contests, what is the maximum amount of luck she can have after competing in all the preliminary contests? This value may be negative. For example, K equals 2 and blah blah blah. Yeah, they go on to describe it, but again, I think HackerRank, the wording with this one is not super strong, and it's kind of confusing. It's best to just look at the sample input and kind of decode it from there. I'll post an image on the screen that basically shows you how we're going to break this input down. So we have these first two numbers coming in, which we'll call N and K. N is the number of preliminary contests, so we have 6 here, and as we can see, we have 1, 2, 3, 4, 5, 6 contests, and K is the maximum number of important contests that Lena can lose, so 3 is the maximum number of important contests Lena can lose. The first number in the list is the luck balanced, right? And one of our constraints here is that the luck balance is more than or equal to 1 and less than or equal to 10 to the 4th degree. So we can't have, you know, a million, or I don't know what 10 to the 4th degree is. Well, that's what 10 to the 4th degree is. Luck balance for this sample input doesn't get any higher than 10 here. So we're working with pretty easy numbers. And then TI is the importance rating, which again will only be 1 or 0. So we can kind of split I guess split isn't the right word. These are the important contests, and these are the not important contests, right? That's what we get from this. So without further ado, let's just like start writing the code. So wait, where are we here? We are logged into code. Let's get rid of that. Alright, luck balance, let's do it. Alright, so you get rid of all the code that's in there, and we'll start from scratch because we want to learn the C# just by writing it out. So we're going to be using system as always, got those built-in methods, and then we're also going to be using system.collections.generic, which will give us access to some list functionality and the .add extension method that we're going to be using. We'll also be using the system.link directive, which will give us access to .sum and .take, which are important for this solution that we'll be building out. Again, we'll start with a class of solution, and then within this class we'll have the static void main, which takes in a string array, and the command line arguments. If you've been following along and doing some of these C# HackerRank challenges with me, then this setup should be becoming a little bit familiar to you. We'll start with an array of integers, ARR, which is equal to array.convertAll console.readLine split, and we'll do that, and then get the cursor right here. So this is our first line of input. Alright, it will take in the first line of input, split it into an array, and convert that array to integers. Because, as always, the computer is going to take it in as a string. So integer n will be the 0th place of the string, or the integer array that we've just taken in, and integer k will be the first place, or the second digit of the first line, representing the amount of contests Alina can lose. Alright, and then we're going to start with a bit of logic that we haven't seen before on NeCode. This is list, and we'll call it importance, and new list. This is how we instantiate a list, and this list will be important to us to fill with value sets that represent the important contests that we're going to be looking at in the solution to Lena's luck balance contest problem, right? And we will create another list, not importance. You might be able to see where I'm going here. This will hold the values of the not important luck balances. So when we look at that second number, alright, now we're going to start a for loop with variable I as our counter, int I equals 0, I is less than n, and as long as it is less than n, I plus plus. Then we are going to set up another integer array. We'll call this array1, and here we will again convert the lines we are reading, and these are the lines that denote the contest's luck balance and important balance. importance balance, and we are going to split them and take in that second int.parse conversion argument. So we've taken in the next line, splitting them and converting them into integers that we can work with. So if, this is an if statement, if array1, the second character, 0 is the first, 1 is the second, is equal to 1, right? This is our importance, this is like the importance. It represents whether or not it's a 0 or 1. It's going to represent whether or not the the contest is important. If it is equal to 1, so if it is important, then we will importance dot add then we will add the luck balance to the importance list that we built up here. So this list will take in any value we give to it in this for loop. If it has an importance value of 1. So that's a little bit of logic that will help us solve this and deliver the right output. And then we'll create the else not importance dot add, and this obviously is the case where it isn't important. So if array 1 isn't equal to 1, it will equal 0, and then the value or the luck balance will be added to the not importance. Alright, and here is a really important bit of code for this problem. Importance equals importance dot order by descending. Num that arrow num to list. And you're like, what the heck is this? Well, this is basically going to take our list of importance, and it is going to order them by luck balance from the highest to the lowest luck balance. And this will give us essentially the amount of luck that this is a greedy algorithm, right? So we are trying to find the most optimal way of doing this. So by ordering by descending, we're going to basically order out the important contests by the amount of luck balance that they have, right? Again, I don't know what's wrong with Lena here and why this is the way that she approaches contests, but for the sake of solving this, let's not get too subjective about how we think about her approach to the contest. And let's instead just look at this list and realize it's that we want the list to be ordered by the amount of luck balances in the case of the importance. In the case of not importance, we don't really need to do anything with it, right? Alright, so they're going into the list, and here we have our output, console.writeLine. We're going to take in the sum of the not importance added to importance.take k. Now what does .take do? Well, .take is going to essentially, what does .take do again? .take is going to essentially look at our code and return the first specified number of elements. So the specified number of elements is our k. In the case of this input, our K is 3. So it's going to look at our code, our importance list, and take the first 3 and add them up. So when we look at our importance list, we have just ordered it by descending. Again, this is why it's important that we ordered it by descending. It's going to take those first 3, which are 8, 5, and 2, and add them together with this dot sum. Again, these are extension methods. Take, dot sum, they're coming from system.link, I think. Dot take is coming from system.link. Dot sum might, I think, whatever. We're learning here. It's cool. Alright, and then we are going to subtract importance.skipk.sum. And what this does is it essentially takes, it does the opposite of what .take does. It skips the first 3 values of our list and takes the last value. So this is only going to give us 1. So we're adding the not important sum, 15, plus the importance.take sum, which is going to be 15 again, subtracting the importance.skip sum, which is just 1, so 30 minus 1 gives us the output of 29, which is the intended output for the challenge given the input. And if we run the code, we should, there's always a compilation error because, look, we're missing a semicolon. And that's just how it is sometimes. But yeah, so we've passed the sample cases, we can submit the code, we can get our points for it, passing all these test cases, and look, we have passed another, and we've earned our first star, the Need Code account on HackerRank. Yeah, so find me on HackerRank, follow my account, check out the GitHub link in the descriptions. The source code is right there. It's got some comments in it. It might be easier than following along with me at this point. I don't know. And yeah, look forward to more HackerRank challenges being posted to this YouTube. You're helping me learn right now. I'm preparing for interview later in the week, so this is really solid for me. So yeah, let's learn together. C# is cool. C# is fun. GitHub is awesome. HackerRank is awesome. .NET Pearls for C# information is a great resource. The MSDN documentation can be kind of confusing. But yeah, .NET Pearls, check it out. And yeah, keep coding and keep up the good work, everybody. I love you.